Hello. Good morning, everyone. Welcome to the third webinar in the Earth Engine India Users Community on Air webinar series. Those of you who have been here before, welcome back. And for all new viewers, good to have you. I hope you will stick around and come back again and again. So just a quick overview about this activity and this event we are hosting. So this is the monthly Community on Air webinar series that we at the Earth Engine India Users Community we have been putting together for the past few months. The idea, so as a community, we are a bunch of online, we are an online community where Earth Engine enthusiasts and users who work on India-specific questions related to geospatial analysis and satellite data. We have come together and we've formed an online forum for interaction. We have also been doing this webinar series. So the way we have been structuring this webinar series is that in each webinar, we have a showcase of some projects that people in the community have been doing using Earth Engine and other geospatial data. They could be research projects, they could be just data exploration and building of apps and teaching resources and so on. So we have users come on and showcase the work that they have done and share the power of Earth Engine that they saw in their projects. Then we have a segment on sharing some technical skills related to Earth Engine. So we've been doing some classification related. So in one of the webinars earlier, we had a segment on how to do land cover classification using remote sense data and training data that you bring to the table and so on. So, and then at the end, we have a segment where we have live Q&A. So that's where all of you as users, you'd be most welcome to ask questions to the speakers about whatever they have presented, anything about Earth Engine that you've been wanting to ask. And at the end, we have about 15 minutes set aside just to take questions from participants. And we do our best to answer all the questions that come up. So feel free to type your questions whenever they strike you during the webinar, and we'll monitor them and we'll come back to them at the very end. So without further ado, we'll get started with today's webinar series. Today we have a bunch of guest speakers. We have lots of things lined up. So just in the interest of time, I will skip the usual round of introductions we have, where all of us go around and introduce ourselves. All of us, when we come on to give our segment of the presentation, we'll introduce ourselves at that time. Anyway, just to start off, my name is Pradeep. I'll be moderating this as we go through these presentations. For now, getting things started, first up, we'll have Ujjwal from Google India. He's an Earth Engine expert. He has been on our webinar many times before. So he has a few interesting announcements to make on some exciting events coming up next. Ujjwal?
Yeah. Thanks, Pradeep. Good morning, everyone. It's great to be here and looking forward to the other presentations and learning about charting and stuff like that. So we have a very exciting announcement. Some of you may have seen on our developers list and our community list that we are putting together the first ever summit for advanced users. And that summit is going to be in India in Google Bangalore office. So it'll be interesting to get all the users who have been using Earth Engine, who are familiar with Earth Engine, and get them to learn about advanced skills. So let me just present my screen. I can show you the summit website, and I can take you through the agenda. We would really love to have more participation. And if you are an user who's kind of been familiar with the Earth Engine, but you want to take your skills to the next level, you want to meet other users, all of us on the Hangouts call here, I think we'll all be here in the summit. So it'd be great to meet everybody in person. So let me share my screen and show you about the summit. Hope you can see my screen. I think, Pradeep, you may have to pin my screen. Yeah. So this is the website. I'll shortly post it on the live chat as well, so you can check it out. Uh, the summit is from 15th to 17th March. It's a 3-day summit, but we have the first day for higher education participants, so people who are teaching at universities, faculty, and professors. Neeti will be there. She'll be talking about how she's using Earth Engine in her classroom. We'll have David Sa from University of San Francisco, who'll also be there talking about how he's been incorporating Earth Engine in teaching remote sensing. The next 2 days, 16th and 17th March, they are the ones that is open for all the other users who are interested in learning about advanced Earth Engine. So I'll show you the agenda, what the agenda looks like. We'll have a lot of sessions covering wide variety of topics, including things like how to use TensorFlow along with Earth Engine, how to do use the Python API, how to build Earth Engine apps, how to do image segmentation. So you can see the agenda here. We'll also have what we're calling a buildathon, which is a group of folks get together, decide a problem that they want to work on, and solve it over the 2 days. And we'll have all of the Google team members. We have a bunch of them a bunch of our developers and developer relations folks flying from Mountain View coming to the office. We'll all be here to help you. And the idea would be that you kind of spend the time over 2 days and solve an interesting problem using Earth Engine. So you can check out this website and the agenda. If you go to the register tab, you fill out a form. And we are asking folks to just provide an example of how they've been using Earth Engine. This is to ensure that people that we gather at the summit know the basics of Earth Engine and they can get the most out of the summit. So look forward to great participation and seeing everybody in person at this event. Thank you. So that's all I have, Pradeep.
Yeah, thanks, Ujjwal. Thanks a lot. Yeah, that's a really exciting event that we are all looking forward to, and we'd like to meet as many of you viewers as possible in person at that time. Moving on to the next section, we have our project showcases today. We have two, in fact. We'll begin with Raj Bhagat Palinswamy. Raj?
Good morning, everyone. Thank you, Pradeep. My name is Raj Bhagat. I work in World Resources Institute, and we are actually a research to policy organization. So as a research to policy organization, actually, we use a lot of data, and I'll be just showing you how Google Earth Engine has helped in it. And also in scaling of our research. So I work in urban development and water resources. So one of the key problems that we face in India, at least, is the massive urbanization that has been happening in the country since 1990. And using standalone computers and everything, people have been doing classification for a long period of time. But right now, since we are focusing on a vast geography of India, and you need massive computing and for this massive data, we have switched to Google Earth Engine actually. So some of you might have been trained in how to classify images for the basic landforms, etc. During the previous webinars. But there are so many versions of land use, land cover classifications. So many results have been achieved, each one differing. There are lots of these things that have come up post Google Earth Engine's opening up of platform. And I'll show you some of the results that have come from us. So what we did was we were studying actually top 18 cities in India, and we wanted to see how they were growing at least within a 50-kilometer radius from the center of the city. So what you can see the statistics that's seen over here. It's a massive expansion, 5,400 to 10,600 square kilometers within this region, and this is where entire India has been moving. These are the biggest 18 cities. But when we go to the government, it has become like
Raj,
think
you may be
I
on the wrong slide. I can still see in the first slide, I think, of yours.
sorry, is it moving?
Yeah, I can still see a slide, algal bloom observations. That's the one that's on the live stream. If you are switching slides, okay.
Is it fine now? Sorry, is it fine now?
Yeah, it's fine now, but you can still make it full screen.
It is full, I guess. Give me a minute.
Okay, go ahead. Go ahead. Sorry.
Sorry, guys. So yeah, you can notice the statistics that it has grown pretty fast. But governments need more information from this. It's not just where it is expanding and when it expanded. They also wanted to know like why is this expansion happening. So here we used Google Earth Engine in a very new scale, a machine learning on the top of machine learning to figure out why urbanization is happening. So we came up with this model using a lot of ground data, using the machine learning methods in Google Earth Engine. We came up with this model, and it tells like what is the characteristics of urbanization. That is, whether the urbanization in that city is just because the town is expanding, or if it is a new special economic zone or an industrial area coming in, or it is just the neighboring town that is expanding.
So
So
Raj, to interrupt again, I think your slides are still showing the algal blooms, so we are not able to see the correct slide.
okay, I'll reshare. Sorry, I'll reshare again. Is it fine now?
Yeah.
So which is the slide you want to be speaking to, and we will confirm whether that we are seeing that.
Is this the monitoring urban expansion one?
Right. And
Yeah.
can you just navigate one or two, and we will make sure it's happening?
Understanding urbanization is the
Yep.
one right now? Yeah, great. So yeah, the land use land cover maps were created using Google Earth Engine, but we wanted to build upon that data. So we went with another machine learning model over the existing land use land cover maps, which is to understand what type of urbanization that is going on. That is, whether is the town expanding or whether it is a special economic zone. So I have just shown the results over here. It is a machine learning model that was built initially for Bangalore, and later we expanded it for all the 18 cities. So the area in red is shown as the sprawl or infill, that is the town expanding on itself. And then the areas in blue are special projects like airport or industrial area. You can see the Bangalore airport in the north. You can see the Jigani Bommasandra industrial area and the Bidari industrial area that is shown in blue. And the neighboring towns are shown in yellow. That is a small town or a village that began expanding because this city began expanding. So you can see Hosur expanding pretty much, and that kind of thing. And the green color indicates corridors. That is the development that is happening in corridors. This data is pretty useful for the government because you can now understand why this urbanization is happening and what is causing it, and whether we have plans in place for that. For example, the corridor expansion, there are no plans. So in order to do that, this is a idea that we had in our heads, what we see when we see in roads, and we wanted to do that in a machine learning environment, and using Earth Engine we did that. So the best part about Earth Engine is that you can scale this up. That is, it is not just Bangalore you will be able to do for the top 80 cities. So this is the result that came out of it. You can notice that for some cities like Delhi, the expansion of other towns, which is shown in yellow, is nearly 63%. That is, Delhi has these Gurgaon, Faridabad, Ghaziabad, and Noida. Those are expanding in a pretty big scale. So these kind of things, and in some cases like Jaipur, it was just the city growing larger in its peripheries. So you can see the red in that 67%. And also in some cases like Nagpur or Surat, you can see that the majority of the growth is happening because of strategic projects. These are SEZs and those kind of things. In some cases, the corridor expansion is pretty high. So this begins, this kind of insights we were able to build because of the Earth Engine platform, and we were able to test it, and we were able to scale it easily. And otherwise, it's everyone knows. I think it is downloading all these satellite images and testing, etc. So the availability of the machine learning models and also the data made it simpler for us. So this is one of the research, and we were able to inform the government what is causing the growth and where it is focused, which allows them to build plans, for managing this expansion. So the other work that we do is monitoring water bodies using Google Earth Engine. So currently, actually, we have a model that works for surface area monitoring. That is the area, how much it is growing, etc., etc. So this is the sample here is from the Kaveri watershed. So you can see that in this monsoon, how it began filling up using radar data. So we built a model over that to calculate the surface area, which is shown in the graph in your left side, and you can see through the monsoon. This is the chart is actually from 2017 because we just thought it will be good to show that. So we have been doing this for 2 years right now. So to see which lakes have been expanding and which have been shrinking, etc. So this is for surface area. Currently, we are trying to integrate some ground data with GPS devices to bring in volumetric analysis in it as well. So we are expecting this to be ready by this year, and that is the thing. So biggest problems that we face in remote sensing is that we have to provide right data at the right time at the right place. So when we have issues, for example, if we are dealing with some events, say it is flood, landslides, or crop fires, these are events that could happen in any place at any time, and we will not be able to easily predict it. We can predict it, but it will be very difficult, and that means you have a very short frame of time to map all these. In such cases, Google Earth Engine has been very, very beneficial. So what you see is that the flooding in Kodagu, we were able to map to a little bit, at least in the agricultural fields, which was pretty much a starting point for mapping the floods. The other work that we did for Kodagu is Coorg district in Karnataka, where there were immense landslides during the last August, and we began classifying Sentinel-based images to obtain the areas that were affected by the landslide. So what you see over here as in the left side as a GIF file is the extracted landslide affected area that is draped over Google Maps satellite version. So before landslides and after landslides, you can see how much it has affected, and you can thereby calculate the area, etc., etc. So many NGOs and the government has been using this data. They wanted, we ourselves have been recommending them to come into Earth Engine so that they can easily do it by themselves. So the other issue that we recently had to map was crop fires. And you can see that this was an animation. Actually, the code for animation was developed by Janadi, I think, and we used the same for animating across crop fires, and you can notice how they were happening in Punjab and Haryana. So we brought up statistics. This data is actually from MODIS, and we were able to track how many crop fires are happening in Punjab and Haryana in each district and taluk actually. So that is one. There is an app as well. We had published it some time ago that will give you where the crop fires happen. So the new app feature, which is pretty much like a WYSIWYG type, and it is pretty easy because we can test it in the on the go. we have been doing some kind of algal bloom observations. Algal blooms are the ones that happen over the lakes due to increased phosphate content. This is pollution, and it happens usually in the mid course of a river. If there is a dam or something like that, it will happen. So we created an app for the government and the public to view where these algal blooms are happening. So you can see all these green, fluorescent green, etc. So these algal blooms are, some of them are toxic. Not everything is toxic, but it is a good indirect indicator of water quality. And we created an app. Actually, it was a very, very easy one. So it was just click and go, etc. So you can choose the reservoir that you wanted to visualize, and it will show whether show the algal bloom observations that are made in that time period. So the other app that we developed was for Chennai. We were using the same classification methodologies and the thresholding actually on Sentinel-1 radar data, and we were able to create this app where you can slide through between 2017 and 2018. And in 2017, you can see a lot of these lakes are full, and in 2018, you can see that they are pretty much empty. And this was very, very helpful because we were able to create a massive awareness campaign on how the water crisis is growing in Chennai. And actually, right now it is still January. February right now, but by June or something like that, Chennai will be in a very deep crisis. So before the crisis happens, we wanted to warn them, and the app was pretty helpful, and also the data from that. So you can notice that the big one is the Chembarambakam Lake that was flooding in 2015, and this year it is not having even 5% water actually. So these kind of things we were doing a lot of these using Google Earth Engine actually. A good majority of the concepts, it's not just about doing all these. Before the advent of Earth Engine, we were not sure whether we will get the intended results. We were not able to test it in the sense if testing takes lots of our resources. We have to download the images, we have to spend time in processing it, etc., etc. But now the testing and scaling has become pretty easier. That is why we have been shifting most of our research to Earth Engine. And
Raj, just a time check. Could you close up in a minute?
Sure. Okay. I'm done actually. So you can reach out to me personally, or if you have questions, just post it. And if anyone wants any links or ideas, we can share as well. Yeah. Thank you, Pradeep. I'm done.
Thanks a lot, Raj. That was a lot of work, lots of different aspects, all addressed using Earth Engine and remote sense data. That was a really very valuable to hear, I think, from someone who's actually done it. Moving on, so we will let's have Dr. Neeti, who will speak to us about using Earth Engine in lots of the teaching she's been doing. Dr. Neeti?
Hello, everyone. It's nice to be here. I'm faculty at Terry School of Advanced Studies in the Department of Natural Resources. I'm also program coordinator of MSc Geoinformatics program. So I do a lot of teaching mostly in geoinformatics. For geoinformatics, I teach geoinformatics students as well as other environmental studies students. So I'm going to talk about, I was given the topic. I will just share the screen. Is it visible to everyone? So I was given the...
Dr. Neeti, your screen is not visible yet. It's only you who's visible.
Okay. I will try again. Is it now visible?
Yes, now it's visible. I can see the PowerPoint slides.
Okay. Okay, so I'll be talking about teaching remote sensing GIS using Earth Engine in university. So as we know that geoinformatics or GIS and remote sensing, which is also part of the geoinformatics, it's a quite a multidisciplinary field, and we can think as amalgamation of geospatial technology, geographical analysis, information science, so bundle of disciplines combining together. And so at the end, the people who are doing the geospatial work could be geographer, environmentalist, mathematician, statistician, so very varied in nature. Okay, so uh, to have these geospatial experts, we get students from very different background. Some students having the undergrad degree in geography, environmental science, botany, mathematics, statistics, and or even engineering and economics background they come from. So so when we look at geoinformatics program in higher education, especially when students come after their graduation with having expertise in or undergraduate degree in different discipline, so here is we have tried to map it with respect to what MHRD has come up with, geospatial task force. They came up with this pyramid where it is like, okay, first level is workforce for mapping, surveying, GIS operation. Second level is creating technical geospatial professionals, and then geospatial experts. So basically, we can see these levels as concept building to skill building. So in the same way, at TerrySAS, we have tried to build our courses such that first semester we focus on spatial thinking, because a lot of times when people come from different backgrounds, students come from different background, they do not have that spatial thinking in their mind. So we need to create that phenomena or things are happening spatially. There is changes, there is variability in space. And there we teach fundamental concepts of remote sensing, cartography, GIS, and even fundamentals of programming. Because a lot of time when students come from geography background or some other economics background, many times students are not have not done before any programming. So that logical thinking need to be built. And then semester 2 comes where we focus more on skill-based courses, where starting from spatial statistics, spatial modeling, image processing. Here we have introduced Python and Google Earth Engine. So having the concept of Python, that also helps in scripting Google Earth Engine, and the students learn whatever concept they have learned in remote sensing or GIS, they can implement using platform of Google Earth Engine. And then in third semester, we have advanced courses where we teach machine learning, spatial simulation, time series analysis, and so on. So, and at the end, whatever we are teaching in 3 semesters, students take up in the 4th semester as master's thesis and build a project. They build project and do a 4 months long project. So if I see as Earth Engine in geoinformatics curriculum, it's basically Earth Engine. To get started with Earth Engine, when students are come from varying background, step 1 is giving them the domain knowledge as well as basics of programming. Then step 2 is introducing them to Earth Engine platform, where the same analysis which they started in step 1 or in the previous semester, they can build upon that and do the analysis and get comfortable with Earth Engine, so that then the third stage is where we can use it to the full strength of Earth Engine, where we can really take large data set, large area mapping. We can do using using Earth observation data set, which is available for free in Earth Engine, or different advanced algorithm, whether it is machine learning or something else. So in TerrySAS, we have introduced 2 courses where we are directly using Google Earth Engine, programming in geoinformatics, where we introduce the concept, and then in the advanced stage, it is geocomputation, where students will be doing image time series analysis and then applying different machine learning algorithm for classification and so on. So the idea is that once students get comfortable with the platform, then they can really make use of it for the advanced analysis. Here are some of the example I will give. So first is here, like again, the concept of sensor and different types of Earth observation data set is already built as at the stage 1, where students learn the concept of remote sensing, learn the different fundamentals of remote sensing. Here it is an example where a student could visualize Landsat 8 data over Delhi region. So just going through the concept of like, okay, how do I do true color composite or false color composite and so on. So this is one example. Here another example is like, okay, students learn about image enhancement. So how do we do NDVI over certain area? So once we know how to do NDVI, the next stage is, okay, can I see the spatio-temporal pattern over central India? So then the time series analysis will come into picture. That is the next stage, third stage. Here, another one is like, until now I was talking more about the image processing. Here, another one is with respect to geoprocessing, where a student can use the vector data, whatever is there. For example, here it is given identifying reason to apply pesticide in a forested area within 200 meter of infested point. So already students have built or have understood the concept how to do this in a desktop based software. But now in Google Earth Engine, it could make it one could make it more efficient and do the same analysis. But what I'm trying to say here is that, okay, geoprocessing concept students know, but now one can learn how to do it in Google Earth Engine, so that he or she is more comfortable to go to the advanced stage. Here is another example where this is one of my students' thesis work. She's still working on it. It just started a month ago. So where she's interested in understanding incidences of malaria, how it is changing over time across different states in India. So you can see in the left side, there is a map where it is showing trend in malaria incidences. The data was from 2004 to 2018. So you can see that there is the dark red, the brown or red color that is showing where there is increase in the incidences over time, over last 15 years. So then we need to look at what are the biophysical drivers, where we need to look at rainfall, vegetation, and all these data sets over time. So from 2004 until 2018, if we start doing a desktop, it will take really long time. So using cloud computing system of Google Earth Engine, we can really do it much faster, much efficient way student can do it, and get the result where we can understand whatever pattern we are seeing, in the malaria incidences, how it is affected by different biophysical drivers. So the next step here is going to be, after extracting all the biophysical variables, the next step is doing some kind of regression, so that she can link it, that whatever the changes in biophysical variables are there, how it is related to change in the malaria incidence, if there is any relationship. So these are some of the examples of how we see as an educator that how Google Earth Engine can really help in building the concept, and how it can be used for different projects and developing the skill of student. So as a whole, I see Earth Engine for remote sensing GIS teaching in university. First step is definitely domain concept building using desktop-based software. But now, once the student has developed that concept, now how it can be used for in the cloud computing concept or an Earth Engine, and then for the real world project like large area mapping, monitoring using multi-sensor Earth observation data set, or from taking the data set from different sources and integrating it on one platform, their Earth Engine can play a great role. So then we will have experts who can do the work much more efficiently and in a very fast manner. So thank you. So I have given my contact address, that is neeti.squad@gmail.com. You can contact me if you have any question, or you can ask online. Thank you. Back to Pradeep.
Thank you. Thanks, Dr. Neeti. That was great. That's a great overview of how to bring people from very diverse backgrounds up to speed with spatial thinking and desktop-based analysis and scaling all the way up to cloud-based services. That's really great. Good to know that all of this is now part of fundamental teaching in graduate school level. So I will next speak for a few minutes about charting in Earth Engine. That's part of the skill sharing thing we have planned for today. So charting was one of the topics that came up as a specific request in one of the earlier webinars. So we thought many of us also were struggling with it. We also found that that's a common bottleneck. So we thought we'll put together a little skill sharing slides for that. So I'll go over the slides I have for that. Okay, so quickly as a broad overview, so many of us who've been working with data and analyzing them and all that, we know that visualization is crucial in the entire workflow, and particularly in the exploration part. Right, here's a really nice a pictorial I have of the workflow in data analysis. This was put together by people in the R community, which is an open source data analysis, data science platform. So this really nicely illustrates the flow that a typical data science, data exploration project might take. You bring in the data, do some initial tidying, and then do this, on most occasions, a repetitive, iterative process of transforming, visualizing, modeling, and then communicating. All of us are quite familiar with how visualizations are very crucial in the communication stage, where whether it is a report or a journal publication or a presentation, the results and data have to be visualized. But one of the things I wanted to emphasize here is visualization is a very key component of exploration itself, because it forms part of this very tight iterative loop of data exploration and trying out various ideas before you actually hit upon the actual thing you want to do. So visualization clearly is very important in this whole workflow. But when we think of cloud computing platforms, many of us who don't have background in that and are new to it and are also may not be experts, we wonder how to do the visualizations in the cloud itself, because data handling, we will be handling large amounts of data. So we end up falling back on the option of having to export and download and use other options for visualizations, which is definitely a legitimate way to go. But sometimes it might be very powerful to also have visualization capabilities in the cloud computing platform itself. And that's exactly what Earth Engine allows us to do. So you must all be familiar by now with the code editor layout. So we have the map window here and the console window here, which are the two primary areas to show visualizations in. And maps show, of course, maps, and the console shows lots of printed values. We'll now focus on charting, or plotting, as some of us might be familiar with the other term. So charting is also possible in Earth Engine using this very same code editor interface, and values charted can be shown maybe on the map, maybe on the console, depending on whichever is convenient. And of course, I have to note that these charts can also be embedded in Earth Engine apps, which is now increasingly very popular as a communication tool for many things that has been done. And some of this that I just now mentioned was also reiterated by what Raj said a few minutes ago about how he has built apps for many things they've done. So charting is very powerful to have right there in the code editor framework, and that's exactly what I thought we will go over today. So to begin with, I want to point out that the user guide for Earth Engine has documentation. There's a section-wise description of how to do the charting. So here is an embedded link for you to go back and look at that page and follow along with code examples. But one of the things that I thought was missing there is just a logical organization of what kind of things you might do, what kind of charting functions you might invoke, depending on what kind of data you're working with and what you want to do with them. So if you begin here on the left side of the screen, we typically start with wondering what kind of data I have. So it might either be a raster or a table, and depending on what it is, you can navigate through this flowchart from left to right, and you will know what is possible to do and what function you might be interested in exploring. So we'll just go through this broad framework quickly, just so that we'll have a visual on the overall lay of the land for charting in Earth Engine. So to begin with, if you have your data in a table, so typically that would come in a feature collection. There are two options for charting values in a feature collection. We'll just quickly look at what that might be. So here's a visual on. So if you have a table, it's probably a nice little rectangular format. There are features on the left side, and there are all the properties on top, right? So you might want to do one of two things: plot all properties of each feature, and that you can do using chart.feature.byFeature. On the other hand, you might take the same table and want to plot each feature on the horizontal axis, but have on the vertical axis different properties. So if you notice, the properties and the features here are just flipped, and both the options are available. Here's so the documentation, the user guide has description for all of this. I'm just looking to show here some of the capabilities and what's going on. So if you were to use the chart feature by property, then here's an example where, let's say you have 3 features: Fairbanks, Phoenix, and Honolulu, and you have temperatures for different times of the year. You have temperatures on the vertical axis, and the color-coded data series are based on the feature. If you wanted the other way around, where the features are on the horizontal axis, but the temperatures are grouped according to the feature, then you would do the other way around, where the feature, which is color-coded here in the orange, so that goes down here in the horizontal axis, and all the legend that go into the vertical axis have to go in the Y properties. So that same data table plotted in 2 different ways. This is how it works. And here's for each of these, there is the script that will do the plotting. So you can go back and take a look whenever you find the time. Then let us say your data is not in a table, but it's in a raster. In which case, we have 2 options. Either it's in a form of a single image or an image collection. Let's say you have it in an image. Then you have 2 things you can do with it, 2 options. So if you have a single image, you have to plot band values, but you can plot them in 2 slightly different ways. You go in here, so you have the image, and let's say you have one image but with multiple regions, then you can plot the band values in those multiple regions using this function call. But if you have an image which is all different classes, they're all categorized in group based on class values, then you can use charts. As you notice, regions are spatially contiguous, but classes might be quite dispersed, but they can still be charted. So here's again a quick overview of how those are done. So if you look at, if you want to chart one image with multiple regions, all the regions would go in here, right? So on the vertical axis, they are grouped by region, but all the band values go here on the horizontal axis. So for each of the band, what are the values in the various regions? This is how we do it. Again, this is the script link. If you wanted to do the same kind of charting, but by class, here you have a region where the class data is available, like water, forest, shrub, grass, and urban, but you wanted the band values for all of them, you would use this function and do it this way. As you notice, it plots all bands, but for one region, but all classes. Again, the script link is right there. Going back to, again, the map of how we are thinking about this. So we did data table as a feature collection, data raster as an image, but data in a raster format can also be in an image collection. And if it's in an image collection, you again have 2 things you can do with them. Again, of course, plot band values, but either as a time series or as a day of year series. So we'll look at what those might be. Time series first. So you have an entire image collection. Let's say here's a pictorial representation. So on the horizontal axis is the time axis. So you might have two scenarios where you have an image collection and you're interested in one region in that image collection. So you can chart all the band values in one region over an entire image collection accessed by time using this function. If you have multiple regions, then you would pick one band to plot, but you will plot that one band across all regions in your image collection. So quick pictorials on how that might look. So here's an example of image, just one image, one region, all bands. So the time axis is on the horizontal axis. The various bands are color coded depending on which data series that was. Again, script link is available. If you had multiple regions, but one image, then you have multiple regions, but you also have to select a band. And for that selected band, over these regions, you can plot a time series of what the values were like. So if you see, all the regions went up here in legend, and all the time ticks went on the horizontal axis. Script link is available again. Going back to our mental map, the last one in this map is image collection, the band values plotted as a day of year series. So what would that be? So just a quick overview of what a day of year series might be. So again, you're thinking of an image collection. It's accessed by time. So it might go, it is a multiple year image collection, let's say year 1, 2, 3, 4. But if you think about it, for each year, day of year goes from 1 to 365, let's say 365, 365, 366, and that repeats again. And if your question is, I'm interested in a particular day of year, but how that changed over multiple years, then you would wrap this around on itself year-wise, and all the day of years will line up like this, and you would combine them somehow. And this is and then you would get a chart with horizontal axis going from 1 to 365, and that's the day of year series. There are 3 options for day of year series: one region, multiple regions, all years, stuff like that. We'll quickly look at how to do that. Here's a way to do all years, one region. If you wanted to do year-wise, then you can have them plotted year-wise like this using DOI series by year. If you wanted to plot them by region, then you can give them the regions and select a band and plot them by day of year. Again, script link is available for this. So this is all the things that I have in this flow chart. So if you want to think about what data you have and how to plot them, these are the various options. These are the functions. All of these are clickable, and you can go down to those examples. But as I finish up, I wanted to also point out that there are a couple more options that I wasn't able to fit into that chart for the lack of time. So I'm just listing them here. It's also possible to plot histograms using these functions for whether it's a feature collection or an image. You can plot group data in tabular format. You can also plot arrays. And these links take you to documentation on the user guide to do the charting. That's what I had for the charting part. I guess I'll stop sharing for now, and we'll all congregate again. We'll get together to take questions and answers. So all questions and answers are welcome. We have, in addition to all of our speakers, we also have Craig and MD Madhusudan, who are, all of us are here to help with whatever questions you guys might have. So let's get to questions.
Thanks, Pradeep. That was really good. We have questions for Raj right at the beginning. So, Raj,
Okay.
do you want to have a go? You can say the question out loud and then your response.
Sure. I'll go with the last question first, which is from Shubham Gupta, asking how was Sentinel helpful in mapping landslides? Which Sentinel satellite was used and how? So the one shown in the presentation is actually Sentinel-2. but both Sentinel-1 and Sentinel-2 could be used. And Sentinel-1 is slightly complex, but it is still useful. In case of Sentinel-2, what was shown here is that we did a basic image segmentation based on NDVI change, barren index change, and we detected whether the vegetated area became barren suddenly, etc. And then we classified the images for Sentinel-2. That's how, and then we clipped the landslide area alone. So there was a sudden reduction in particularly in near infrared band in Sentinel-2, for example. This is how the map that was shown in the slides were prepared. And that answers the second question as well. The landslide affected zones was based on the Sentinel-2 map. The Sentinel-1, I didn't share it here. Sentinel-2 images were classified. Multiple images, actually, cloud-free images for the region were classified. And that is how we arrived at that. The other question is, what exactly is sprawl here? A sprawl is the concept is that an urban area expands in XY axis. That is, if a current city has a border at say 30 kilometers, the city is ending. After a few years, it will be ending after like another 2 kilometers or something like that. It would have expanded. This is the sprawl. So the it is part of the 5 classes that we used. So one is sprawl growth. The other types of growth are not dependent on the boundary of the city. It might be like randomly, it might be in a highway, it might be a special economic zone that was planned based on in random place. I mean, they would have gotten land somewhere and suddenly the growth would have started because of that. Sprawl growth is, however, like the natural expansion of city. So today there might be 10 houses in this area, then tomorrow it will become another 11 houses, etc. And it goes on. And the city slowly expands. That is sprawl. I hope these answers the questions.
Thanks, Raj. Pradeep, do you want to take? I think there's a question for you.
Yeah, sure. Yeah, sure. So the question is, how might one do a week of the year chart? That is a good question. um, first off, there is no canned function like the day of year series function. There is no day of week series function already available. So you will have to. So one of the things that's implicit in day of year series charts is that you have to tell it what kind of reduction you want it to do over the various points that overlap across day of years. So that you have to do immaterial, even in case of day of week chart. But I'm guessing, I'm thinking out loud here, I'm guessing you will have to do a whole lot of data wrangling yourself to organize it so that you reduce the appropriate values that correspond to the day of week, and then line it up somehow either in a table or an image collection so that you will be able to take advantage of one of the other functions. I think day of year series already comes, so the day of year comes baked into it. So that's how I understand it. So you cannot transform it to do day of week somehow. You just have to think about how to organize your data either in a table or an image collection, and use one of the other functions to chart day of week. That's how much I know. I can think about it. Do you have anything to add, Madhu?
I think what I would use would be the image series and series by region option. And like you rightly said, I think if you had an appropriate reducer, you reduce the data from daily data, I presume you would reduce it to a weekly data. And then you have a series that is weeks instead of days of year. And that can easily be mapped, charted out using the image series versions of the charts that you put out there.
I don't think we have any more questions. If anyone still has questions, you can still write in.
Just to
If
add
not,
this question,
sorry.
uh,
Yeah, sure, go ahead.
that UI.chart by array. So you'll have to organize your data as an array and then use it. So that's a very generic method where it just takes any array of any dimension and you can plot those. So you'll have to just group your data by day of the week and create an array and then chart it. So uh, it's not a kind of as straightforward as just calling one charting function. You'll have to do some data wrangling.
Yeah, so the arrays, yes, it's a very flexible data type. It can take several dimensions. I don't know if there's even a limit to how many dimensions it can take, but it can take lots of dimensions. So lots of dimensions, and it can be transformed into images and all of that. So that's a very powerful, very flexible data type, which I did not get into, which I don't really understand very well. I did not get into it today, but that is something very powerful and definitely worth looking into. Thanks, Ujjwal.
Yeah, and I think I should also plug one of my kind of one filter that normally beginners don't realize that is available. It's very useful when you kind of get into this kind of territory. Is a filter called calendar range. So ee.filter.calendar range. So instead of filtering by say start and end dates, you can filter by a unit of time, which is day, week, month. So in this case, if you want to do filter, say, give me the first day of the week. So you would say, calendar range 1 week. So then, you will get the day one of every week of all your time series. So this is probably the filter you can use to filter out data and then plot it.
Yeah, I think so. We can wrap up there. I'm going to mention a couple of links that we have. So I've shared links in the chat window of the live stream for any of you who would like to suggest topics for future webinars. And also, we have recently started city meetups. So in Bangalore, Pradeep and Madhu recently had one. They can tell you a little bit about it. But we want to also start city meetups in other cities. So there's a link in the chat window and on the forums, the Earth Engine India Community Forum, where you can sign up for city meetups. So we'd like to see participation from you guys there also. So that'd be great. Pradeep, if you want to talk a little bit about the meetups, or else we could wrap up.
Yeah, Madhu, do you want to say something?
Sorry. Yeah, we thought it's useful to complement the online interactions that we have with the webinar like this with some face-to-face meetings, because one is able to then customize what kind of help people need, what kind of resources would be useful to people, and to do this in a way that's much more personalized. So we thought it would be, and given that there are now critical masses of people in many of the cities where trainings have been held or people have come uh, to various trainings from, and they are working on similar areas like conservation, agriculture, water. We thought it would be useful to start these. So if you have thoughts, do reach out to us and let's see how we can facilitate this. We've started one in Bangalore that's with mostly ecology and conservation kind of groups, but hopefully we will enlarge that in the coming weeks and months.
That sounds great. So I think we can wrap it up here. Thanks to all the speakers. Really in-depth presentations, and I really enjoyed watching them myself today. And please do sign up for the Advanced Summit. Ujjwal has shared the links both on the live stream and on the community forum as well. So look forward to interacting with you guys again. Thank you.
Bye.